Okay, I think everybody can hear me right now. Welcome again to Second International Congress on Ship and Marine Technology. I am Dr. Burak Yıldız. I am the co-chair of this session. In this session, we have 4 presentations, and we will start with a study titled as a study into the economic viability on autonomous shipping, a case study of a 9,400 TEU container vessel, which will be presented by Ivana Jovanovic, right? And welcome again. The floor is yours. You can start your presentation. You have 15 minutes to finish your presentation, and after that, if you have any questions, we will also have extra 5 minutes to answer the questions. So you can start.
Okay, thank you very much. My name is Ivana Jovanovic, and the title of my presentation is a study into the economic viability of autonomous container shipping, a case study of a 9,400 TEU container vessel. Okay, of course. Just a second. Okay. This presentation consists of introduction, state-of-the-art, cost model, case study, results, and conclusion. Autonomous vehicles are appearing in ever more fields, such as aviation, public transportation, and the automotive sector. That is why it is not unlikely to see the deployment of unmanned merchant ship at some point in time. An autonomous vessel is defined as a vessel with next generation modular control systems and a communication technology that will enable wireless monitoring and control functions both on and off board. This will include advanced decision support systems to provide the capability to operate ships remotely under semi or fully autonomous control. Autonomous maritime vehicles are classified into unmanned underwater vehicles and autonomous surface vehicles. Unmanned underwater vehicles are further divided into remotely operated vehicles and autonomous underwater vehicles. On this picture here, we see an example of autonomous underwater vehicles that is used for oil platform inspections. Autonomous surface vehicles are divided into maritime autonomous surface ships and unmanned surface vehicle. Here is a unmanned surface vehicle that is used as a research platform. Maritime autonomous surface ships is commonly used as autonomous ship, and it is further divided into autonomy assisted bridge, periodically manned bridge, periodically unmanned ship, and continuously manned ship, unmanned ship. Here is a picture of Yara Birkeland that is a fully autonomous and fully electric ship built in Norway. The driving force for the development of unmanned and autonomous ships lies within the opportunity of cost savings by fuel reduction and lowering operating and voyage costs, safer waterborne transport by eliminating human error that is responsible for more than 60% of maritime accidents, greener shipping by reducing fuel consumption and opportunity for implementation of renewable energy sources and alternative fuels. Competitive industry by opportunity to grow in size and volume, and also new personnel ashore by creating engaging and exciting maritime jobs. International Maritime Organization has recently defined 4 autonomy degrees for maritime autonomous surface ship. First degree are ship with automated processes and decision support, where seafarers are on board to operate and control shipboard system and functions. Degree 2 and 3 are remotely controlled ship from shore control center. Degree 2, in degree 2 ships, crew are still on board, ready to take action in need, but on the ship degree 3, there are no crew on board. Degree 4 is fully autonomous ship, which has operating system able to make decision and determine action by itself. Crucial part of every autonomous ship are guidance, navigation, and control system, also variety of sensors that enable situational awareness. Reliable communication is also crucial. Depending on the size and usage, it can be internet connection, antenna, or satellite. Also, ground station, which also depending on size and usage, can be mobile device, laptop, another ship, or in the case of merchant autonomous vessel, it is a shore control center. On this picture here, we can see the relationship between autonomous vessel and shore control center. Autonomous vessel through satellite transmit data, and shore control center offers supervision and support. In this study, cost model is used. Ship costs are divided into capital costs, which are related to ship purchase, also operating costs related to crew number, wages, storage, insurance, and administration, and voyage costs, which depend on some typical route. These costs are related to fuel consumption, fuel price, speed, canal dues, port charges, and emission costs. Here we can see the equations used for calculating all costs. Daily operating costs are calculated in their relationship to ship size, and voyage costs are divided to fuel costs, port costs, and emission costs. In this study, emission costs are calculated for 4 different scenarios. First is no tax scenario. Second is current policy scenarios. Third is stated policy scenarios, and fourth is sustainable development scenario, which is required for global sustainable recovery. In this case study, container vessel is used. Costs are calculated for specific route from Amsterdam to Shanghai. Operating time of this ship is 320 days a year, and costs are calculated for the lifespan of 25 years. Firstly, costs are calculated for conventional container vessel, and then using research from European project Moonin, costs are calculated for autonomous container vessel. It is assumed that autonomous vessel is as safe as conventional one. Here we can see results. Here is a diagram of daily cost per container for all 4 scenarios. The first is for conventional, then next to it is for autonomous ship. It can be seen that in all 4 cases, autonomous ship has lower costs with most saving for sustainable development scenario. Here is sensitivity analysis also, which shows that fuel costs influence total costs the most. In conclusion, with stricter emission taxes scenario, the difference in cost between a conventional and autonomous vessel becomes more significant. Economies of scale occur in daily costs per container. Autonomous vessels have lower fuel consumption, resulting in lower fuel and emission costs. Operating costs decrease in autonomous shipping, and port and capital costs increase, but total costs are lower for autonomous vessel. Thank you for your attention, and I'm happy to answer your questions.
Thank you, Ivana. I'm gonna, okay.
Mhm.
Thank you for your nice presentation. Do we have any questions by other participants? So I want to explain that our three participants, the presenters, are here with me at Yıldız Technical University. Just Claire DeMarco is not here. She's connecting via a Zoom link. She's also here. Claire DeMarco, can you hear me? You are here, right?
Yes, I am here. Thank you very much.
We
Yes.
cannot hear you now, but I can see you, but I cannot hear you.
Cannot hear me? Okay, no, I mean, oh, that's bad. Okay.
Okay, at your presentation, we will be hearing you, I hope. Okay. If you
I
have
hope
any
so.
questions,
I can hear her.
really, but not me.
Me
Okay,
and my
I can
colleagues
hear
can
you.
hear
Okay,
you.
okay, okay.
Okay, can you hear me? or
Okay, I
not?
can hear you now.
Okay,
Sorry.
thank you very much. Okay.
Okay, then, if we are ready for the second presentation, I think it's gonna be Maria, right? She will be presenting the study titled Development of an Early Warning System for Marine Pollution in Aquaculture Farms, Interac Adrian Project Series. The floor is yours, Maria.
Thank you. So, hello, I am Marija Korisman from the University of Zagreb, and together with my colleagues from the National Technical University of Athens in Greece, we have prepared a dissemination paper about the Interac Adrian Project Series, that is the development of an early warning system for marine pollution in aquaculture farms. I will give you a short introduction about marine pollution issues and then a detailed scope of the and aims of the CVS project and our methodology in Croatia. Pollution is a global problem found in every sector, including marine shipping, fishing, and aquaculture. The effect of human activities on the environment has been greatly investigated, and UNESCO has stated the following marine pollution issues. Land-based sources account for approximately 80% of marine pollution globally. Different agricultural practices, coastal tourism, different harbors and ports, the damming of river and aquaculture are all sources of marine pollution, threatening coastal and marine habitats. Excessive nutrients from sewage outfalls and agricultural runoff cause low oxygen areas known as dead zones that cause collapses of some ecosystems. The United Nations Environment Program estimated in 2006 that every square mile of ocean contains 46,000 pieces of floating plastic. Today, 60% of the world's major marine ecosystems have been degraded or are being used unsustainably. At the end, the ocean absorbs approximately 26% of the CO2 added to the atmosphere from human activities each year. This causes an increase in ocean acidity by 30%. There are different types of marine pollution issues. Microplastics are the most mentioned one in the general public. They are harmful for marine organisms, causing problems in the digestive tracts and altering feeding behavior, reducing growth and reproduction. Different chemical anomalies for toxic waste and dissolution of chemical compounds, such as from antifouling paints, fishing nets, and biocides, enter the food chain and can directly affect the human health and result in human casualties. Major oil spills are a rare event nowadays, but when released, they cause great environmental disasters. Thanks to a variety of technological and regulatory prevention measures, there is a significant reduction in spillage, but the risk of significant damage remains. Atmospheric emissions are a highly investigated pollution problem, especially in land transport. The emissions are mainly nitrogen oxides, sulfur oxides, and carbon oxides that the ocean absorbs, resulting in an increase of acidification level and global warming. The pollutants affect the marine ecosystem. By raising the level of nutrients such as nitrogen and phosphorus, the ecosystem is endangered by triggering algae bloom. Overgrowth of the algae consumes oxygen and depletes the supply needed for a healthy marine life. As a result, the mortality of marine organisms rises and dead zones occur. Because of that, there are many programs in Europe and worldwide that deal with the problem of marine pollution. Interac Europe program is created to help regional and local governments across Europe to achieve their economic, social, and environmental potential. The main goal is to connect European countries to exchange knowledge and experience, and therefore improve the policy in Europe. The Interac Adrian program is a European transnational program that works to promote cooperation and solidarity between 8 partner states: Albania, Bosnia and Herzegovina, Croatia, Greece, Italy, Montenegro, Serbia, and Slovenia. The Adrian program encourages and invests in regional innovation system, culture and natural heritage, environmental resilience, sustainable transport and mobility. The CVS project stands for the sector-adaptive virtual early warning system for marine pollution and brings together 6 countries in the Adriatic Union area: Greece as the lead partner, Italy, Croatia, Slovenia, Montenegro, and Albania. CVS project is a transnational project aimed at tackling environmental vulnerability and preserving the ecosystem in the Adriatic Union area. By collecting real-time data from a scientific database collected from the sensors and the general public database collected by the SeaViewer mobile application, early warning system will be developed for preventing and managing marine pollution from various sources. The final step of the project is developing an action plan for the amendment of national and regional strategies for enhancing marine and environmental protection. The CVS project has several aims. First aim is to provide detailed monitoring for the water quality within the location with installed sensors covering a wide range in the Adrian area. The next aim is to establish a transnational repository network that will include smart sensors, the mobile application, database and service, control room, and the CVS platform itself. The data obtained from 18 smart sensors installed across the Adrian area will be analyzed, and it will be used to issue alerts to relevant stakeholders for potential marine pollution. By raising awareness has a long-time goal to amend the national and regional strategies. The multi-parameter probe that will be installed in all the 6 partner countries will hold 6 to 9 ports. One port is reserved for the automatic system that cleans the surface periodically, preventing fouling. The multi-parameter probe is determined by battery life length, sampling rate, powering method, and other specifications given by the lead partner. The probe will measure 9 different parameters: temperature, pH level, conductivity, turbidity, dissolved oxygen, oxidation reduction potential, total dissolved solids, and depth. The collected data will be sent to a PC located near the installation location. A purpose-developed software will be used to receive the data from the probes, and a database will be served as a central data repository, receiving and transferring the appropriate data to the appropriate location. The developed web-based platform will be a foundation for the development of an early warning system that will be used for issuing real-time alerts in case of marine pollution incidents. The early warning algorithm will be based on normal, abnormal, and reference values. It will be used to recognize unusual patterns in the parameters value distribution from the existing data. A machine learning algorithm will be used to make marine pollution prediction and issue early warning alerts. The SeaViewer mobile application will allow general public to take pictures of potential marine pollution issues with the correct GPS location and timestamp and a detailed description of the possible issue. The data will be sent to the SeaViewer platform for further analysis, but the photos sent by public users will be checked and validated prior to their uploading. The Croatian coastline occupies most of the eastern Adriatic shoreline, which makes it valuable for this project. The Adriatic Sea is relatively shallow and it's characterized by the mentioned type of shoreline. There are 5 main river drains towards the Adriatic Sea: Neretva, Lika, Zrmanja, Krka, and Cetina, because of which the salinity of the sea is slightly lower. There are different sectors that are currently in progress, aquaculture, fishing, tourism, and transport, and they all affect the Adriatic Sea. The sea view study location is the mouth of the Krka River near Šibenik. This is a Natura 2000 site and a marine protected area, which is characterized by brackish surface water and bottom seawater layer. There are several reasons for choosing an aquaculture farm in the Krka estuary for the sea view study area. First, the low salinity is not tolerable for the mussels and fish, and mortality can occur. Also, the increased copper concentration can be harmful for the mussel embryos as well as for the fish. And at the end, the monitoring of water quality is essential for the growth and the reproduction of species. In Croatia, we have installed one multi-parameter probe, and we have chosen the EXO2 probe by YSI. The study location incorporates a small platform with electricity, and it's protected by a roof, which eliminates the problem with bad weather. The aquaculture farm and the platform are permanently protected by a guard person. Nearby is the marine station, which is used as a logistic support. All the areas are well connected and easily approachable by a research vessel. Data will be collected and exported in various formats, thus adapting the format to the needs of the project. In overview, the project plan that includes the technical and promotional part of the project has been set up. Most of the sensors are installed. Few partners are still waiting, but the network of sensors was already established. The data collecting is in progress, and the first results are being analyzed. The CVS platform is being developed also with the CVS mobile application. Regarding the improvement actions, the data from different national and regional locations is being gathered to achieve to raise great general awareness and enhance marine environmental protection. That will be all for me. If there are any questions, please don't hesitate.
Thank you, Maria, for your nice presentation. It's a well-organized presentation and a nice project. I just want to ask a question. When did this project start?
It started in April 2020.
And when will it be finalized?
The first deadline is October 2022, but because of the COVID and everything, it will be probably delayed for about 8 months.
Ah, okay. I see. Any other questions? No, I think. Okay, if you have questions, then we can also answer at the end of the session. So the third, thank you again, Maria, for your presentation. And the third presentation, it will be presented by Claire DeMarco. And the paper is titled Venture, a virtual and physical experimental towing center for the design of energy efficient seafaring vessels. Claire DeMarco, are you ready for your presentation?
I sure am. Thank you very much. I suppose you're seeing my shared screen, so that should be good.
Yeah, we can.
Okay, excellent. Thank you very much.
So the floor is yours. You can start.
Thank you. Thank you very much for giving me this opportunity to show you and explain our H2020 Venture project. As you correctly said, Venture is the acronym for a virtual and physical experimental towing center for the design of energy efficient seafaring vessels. As you can see, that Venture is in fact a partnership of 3 universities, University of Malta, Strathclyde and Genoa, and a Maltese industrial partner, Naval Architectural Service. The Venture project is in fact a twinning project, which basically focuses on increasing the scientific excellence, research and innovation capacities and profile. University of Malta is in fact the project coordinator, and I am the project leader. The project is 3 years long and started in January 2020 and will end in 2022. Now, as a very brief description, there were a couple of names. Here are the working group, the active members in the Venture team. Perhaps you can recognize some of your Turkish counterparts, also in this partnership. So what is Venture? Venture is a program that obviously, because it is twinning, involves many activities and events for all sorts of people, the academics, technical staff, researchers, and even the general public. And basically, it is divided into 4 main sections. So let us start looking at them very quickly, and I'll just give you a bit of an overview. Let's look at the first one, enhancing scientific and technological capacity. This is a twinning project, and therefore this involves a lot of courses and places for training. So the work package of enhancing scientific and technological capacity basically has some specialist courses, a platform for training, some visits, short visits from Malta to the other universities, partner visits, expert visits, and even technician lab visits. To raise a research profile of the University of Malta and all the other universities, we have developed research groups. Obviously, networking activities is very important, conferences like we are here today, and also cooperation between University of Malta and the maritime industrial partner in Malta itself. To be able to build the human capacity, if you wish, of the maritime professional and academic innovators, the development is of postgraduate research students. So we have conferences, exchanges, mentoring and supervision, secondments, schools, development of joint MSc projects, and also training networks. And obviously, any good H2020 project requires some communication dissemination and exploitation plans through websites, electronic media, so that we can obviously showcase what the venture project is all about. And obviously, we always scientific publications, and for that we also have an online repository. So let us very briefly see perhaps a couple of items in these 4 different groups. So the short specialist courses, we have a number of short specialist courses. We've already had one in July 2020, led by the University of Strathclyde, of the physical towing tank testing for the prediction of ship resistance and propulsion. Obviously, physical means experimental technologies and techniques, and we are focusing on ship resistance measurements and prediction in this particular short specialist course. The second short specialist course, which has just taken place, is the virtual aspects of the physical course we had last year, and this was just held. So it's talking about theories, numerical methods, and during the course we had tutorials of lots of different examples on how to virtually predict the ship resistance and propulsion. And here we have a couple of snippets from the courses themselves. We have one that is coming up right now, perhaps next week. It is going to be held in Genoa, led by the University of Genoa, and it's about the virtual tow tank testing prediction of ship hydrodynamics, focusing on safekeeping. Obviously, we're looking at the modeling, we're looking at numerical methods and models, and therefore we are also going to have a couple of hands-on examples also, and tutorials and demonstrations, and workings on the virtual aspects of the ship hydrodynamics. In fact, we have 6 in total. The virtual hydrodynamic, the virtual course came before the physical one, and University of Strathclyde is going to lead this physical short specialist course. We then have 2 further, which is the state-of-the-art measurement, calibration, and data analysis techniques. And finally, we'll have another final school on the virtual towing tank applications after we have learned all this applications in the marine industry. And that will be led by the Maltese industrial partner, Naval Architectural Services. We also have short-term visits. Unfortunately, this was exactly when COVID hit. And instead of actually visiting the University of Strathclyde, we had an online visit, if you wish, led by Edinburgh Designs. Everybody who deals with tow tanks have obviously heard about Edinburgh Designs, and we had a very enjoyable 3 days on how to design and spec a towing tank. Why do we want to design and spec a towing tank? Because the University of Malta is in fact investing in its own towing tank. Amongst the many towing tanks that we looked at during this course, one particular of interest was the Cranfield University, simply because what we are designing is roughly of the same specifications of about 30 meters long, 1.5 meters wide, you know, and about 2 meters deep as well, for about the same design maximum speed. So that was a very interesting 3 days short-term visit, if you wish. As you can see, we have perhaps 3 other visits as well. Next week, we are going to Genoa to do how to operate and use towing tanks as academic, education, and industrial tools, to see how Genoa will do this. And then we have 2 other visits. One about the cavitation tunnel, again to Genoa, and another at Strathclyde on how to combine CFD with EFD. We also have, at one of our visits, have a partner industrial visit. And basically NAS is our industrial partner in Malta, and we had the first visit, and basically they showcased all the activities and services that they carry out in the company, and also highlighted the different sectors and work within the maritime industry within Malta, where we had a lot of researchers following this very interesting partner industrial visit to see where they can also work in Malta and perhaps also further afield. We have due some experts visits where we'll have visitors coming to the University of Malta, and our technician and lab staff visits unfortunately could not take place because of all the travel restrictions, and we hope that eventually very soon this will start up and run. So moving on, how are we going to raise the research profile of the University of Malta and all the other universities? We have created 3 different research groups, and each research group is to produce a case study every year. So the first resistance and propulsion group in the first year, we looked at the hull roughness on the ship resistance. We investigated a wiggly hull with experimental results and compared them with CFD. The second case study of this resistance and propulsion group, which is currently running, is the numerical and experimental following the ITC guidelines to predict the prediction of high-speed craft in self-propulsion condition. And we're discussing the resistance tests, experimental and numerical, open water propeller tests, experimental and numerical, and obviously propulsion tests. The next research group is the seakeeping and maneuvering. That was the first case study, and we were looking at the interactions between 2 ships during an overtaking maneuver or an encountering operation, both in open sea and even in inland waterways. The second case study for this seakeeping and maneuvering group is to investigate the effects of hull, propeller, rudder interactions. It's a classical, if you wish, research for ships and for academic institutions. The third group is the combined CFD and EFD methods. The first one was basically to investigate the effects of ship velocity on hull form, and this was done through numerical methods and simulation. The second current case study of this group is the analysis of propellers in oblique flow, looking at the bearing forces and with and without cavitation. Okay, so obviously this is presently looking at the the computational, and seeing how we're going to convert all these the forces and all the motion over the propeller experimentally. And here you can see the ideas of the cavitation and the simulation model. One way of raising the research profile is to publish very early on, when the project just started, before we even heard the word COVID, probably. We had the whole consortium in Malta, and Professor Tesdogan from the University of Strathclyde gave us a very good seminar on how to get published. Obviously, to raise a research profile, we have annual postgraduate seminars. We have joint proposal strategies with Genoa, with Strathclyde, with NAS. We have applied for funding through the Transport Malta and Malta Marittima, and we have been awarded the MARSA funds for 2 projects. And we have also won in Malta, every so often, it's not an annual thing, the national contact point of the Horizon 2020 program awards H2020 projects with outstanding potential and capabilities, and the venture project won this award. Obviously, we also want to look for regional funding in Italy, and there's a See Future event next week where we are going to discuss a lot of regional funding and international funding, Horizon Europe. So we are looking for even partners for Horizon Europe, where we can see over here, which is the last point. We are going to be looking for, we're going to network for possible partners for joint doctoral programs if you want the Horizon Europe standard joint doctoral program. Obviously, to build professionals and innovators, our students and other students need exchanges, supervision, and also secondment to industries. And obviously, it would be nice that if there is a joint framework of a MSc program between the universities, and that can widen everybody's knowledge, everybody's experience, and bring them all together. We also have some schools. We've had a data analytics school. We've had a CFD for maritime applications, and also a dynamic simulation of marine systems. Obviously, I mean, you can read what they're all about, but basically, in a nutshell, we've had 3 of the 6 schools. We have the boundary element method on hydrodynamics still to come, how to build a successful research career for our researchers, and energy efficiency in marine engineering applications. Obviously, with all this work, as any H2020 project, as any university would like to do, as any academic would like to do, obviously within, these, if you want, 15 months, we've managed to have we've got 5 journal publications, and we've also managed to get, I believe there are 12 conference papers. Yes, there are 12 conference papers already generated by our consortium. So that's pretty good going in a matter of 15 months. Obviously, we have our own website. It's h2020venture.eu. Every time we have an event, obviously, we put up an electronic newsreel and explain. Obviously, if you do have chance, please do visit it. There are a lot of interesting things to show. And obviously, besides having our email address, we have our email address. And obviously, besides having our website, we will also post on Facebook. So perhaps if you look H2020, you can like the Facebook. You can also like our LinkedIn to keep yourself informed. And when we have something to tweet, we will tweet it away. Okay, so that's all for me. I hope you found our project interesting. It's been going along quite honestly. Also with the COVID, we've managed to progress quite through it. So it is very encouraging, but obviously now we're looking forward to being able to travel, because it seems that travel is now really on the uptake. So again, thank you very much for allowing me to present. And I hope if you have any questions, you would just ask me. Thank you.
Thank you, Demarco. It was a nice presentation. Due to the COVID, it was not possible to see you here, but for the next Congress, we are waiting.
I would have loved. Yes.
We are waiting for you the next one, okay?
Okay, we'll do, definitely. I'll take you up on it.
I'm curious about that, the CFD analysis that you carried out. So you used a commercial CFD package, right?
Yes, we did. Start CCM. It's normally the platform used by University of Strathclyde and Genoa.
Okay. And is it possible to learn the budget of the project?
It's 900,000 in total.
Oh, okay.
It's not remember, this is a twinning program. It is not a research program. So the twinning involves networking, traveling, meeting people, and learning. It involves a lot of travel.
Okay. Thank
Okay.
you again for your nice presentation. Any other questions from other participants? Not for now. Okay. Thank you.
Thank you very much. Thank you.
So, thank you. So we have our last presentation left. It's gonna be environmental analysis of the methanol as an alternative marine fuel. That is gonna be presented by Maya. So if you're ready, you can start, Maya.
Yes. Just, okay. Just a moment. What? Okay. So hello everybody. My name is Maya Perčić and I'm a PhD student at the Faculty of Mechanical Engineering and Naval Architecture at the University of Zagreb in Croatia. Today I'm going to present you a paper called Environmental Analysis of Methanol as an Alternative Marine Fuel. First, I'm going to introduce you to the research background, and after the methodology, the results of the research is going to be presented, the conclusion is going to be stated. One of the most environmental problems nowadays is the air pollution caused by extensive use of fossil fuels. Well, fossil fuel combustion causes exhaust gas that comprises of nitrogen oxides, sulfur oxides, particulate matter, carbon monoxide, and greenhouse gases, which refers to emissions of carbon dioxide, methane, nitrous oxides, and fluorinated gases in low concentration. Well, among different transportation modes, the road transport has a major impact on the transportation emissions. The maritime sector should not be neglected, especially when the negative impact on human health is more pronounced when ships spend much more time near ports and near populated areas, such as ships engaged in short sea shipping do. Regarding the impact of the emissions, the nitrogen and sulfur oxides have a negative impact on the human health, but also on the environment, causing its acidification, while the greenhouse gases have a negative impact on the environment, causing the global warming. The relevant climate agreement, the Paris Agreement, promotes the reduction of CO2 emission, as the CO2 is a major greenhouse gas. This reduction of CO2 emission is often called decarbonization. And according to this Paris Agreement, each sector should participate in its decarbonization. So according to the Paris Agreement, the International Maritime Organization set a new goal for international shipping to reduce its annual greenhouse gas emissions by at least 50% by 2050 compared to 2008 level. Well, the most promising way to reduce greenhouse gas emission is to replace the conventional fuel with alternative, preferably with a zero carbon content, but it's okay if it's a lower carbon content. So among different fuels that are investigated for the use in a shipping sector, methanol is one of them. So methanol is a sulfur-free fuel with low carbon content. It's a lower carbon content leads to lower released greenhouse gas emissions. Methanol has a carbon content around 38%, while for the comparison, diesel has a carbon content around 87%. So there is a great difference in the released emissions. Methanol can be produced from various sources, either fossil methanol or biomethanol. Fossil methanol can be produced from fossil fuel, either natural gas or coal, and it's available and affordable fuel, but it's still fossil fuel. On the other hand, we have biomethanol. Biomethanol is produced from biomass, and it is biofuel, which is usually considered carbon neutral fuel, but its main limitation is that it is expensive and the distribution chains are not so developed. Due to similarity with conventional marine fuel, methanol can be used in existing infrastructure with just a minor modifications regarding low flash temperature. While it can be used in the commercially available dual fuel engine, methanol can also be used as hydrogen carriers in fuel cell systems. In this paper, several methanol types as a potential marine fuels are investigated depending on the methanol origin, whether it's fossil methanol or biomethanol. Well, in this paper, the fossil methanol is produced from natural gas, while there are 6 different types of methanol, and they are produced from willow, switchgrass, forest residue, corn stover, miscanthus, and poplar. The life cycle assessment comparison of the total greenhouse gases, NOx and SOx emissions related to considered fuel, where the currently used diesel-powered ship represent a baseline scenario, and the results of the analysis are illustrated on the ship engaged in the Croatian short sea shipping sector. The environmental impact of these on different types of methanol implemented on board are investigated, where the selected ship is a Ro-Ro passenger ship, i.e. ferry, that is engaged in the Croatian short sea shipping fleet. On the left side of this slide, it is presented the methodology flow. In the first step, there is a ship schedule analysis, which lead to average speed calculation. The third step of the methodology is energy needs analysis, which lead to energy consumption calculation. So energy consumption calculation represents an input parameter for our life cycle assessment software, which is Grid 2020. After that, the life cycle assessment of diesel and life cycle assessment of different types of methanol are performed, and in a final step of the methodology, they are compared. On the right side of the slide, the representative of the Croatian short sea shipping fleet is presented. This ferry operates between 2 settlements, Ploče and Trpanj, and it represents a good candidate for implementation of such alternative fuels such as methanol, due to the proximity of the land, required energy, and the length of the route. So environmental analysis is performed with life cycle assessment, as I stated before, with this LCA software Grid 2020. This environmental assessment considers emissions released through the life cycle of a ship power system, where these emissions can be arranged into 3 phases. First phase is a well-to-pump phase, which refers to emissions related to the fuel cycle. It includes processes from raw material extraction to transportation of raw material to production facility, production fuel, and finally distribution of that fuel to the refueling station. The second phase is pumped wake phase, which refers to the emissions related to the use of fuel in the ship power system, which often refers to the use of fuel for ship operation, combustion of fuel in a ship engine. And finally, the third phase is manufacturing phase, and these emissions are related to the manufacturing process of the main element of a power system, for example, a diesel engine, battery, fuel cell, and so on. So in this paper, total CO2 equivalent emissions, NOx, SOx emissions are investigated to the 20 years of a ship lifetime. In the life cycle assessment of a diesel-powered ship, the processes that are included are diesel engine manufacturing, crude oil recovery, crude oil transport, diesel production, and diesel distribution, and finally combustion of diesel. Well, in the life cycle assessment of methanol-powered ship, along with dual fuel engine manufacturing and combustion of a fuel in a ship engine, we have 2 well-to-pump phases. First one is from methanol, and the second one is of diesel. Since methanol is used in a dual fuel engine, it requires pilot fuel, in this case diesel, to start the combustion. So in a small share, diesel is used as a pilot fuel. In the well-to-pump phase of methanol, the processes that are included are feedstock preparation, methanol production, and methanol distribution. Finally, the results of the life cycle comparison indicated that even fossil methanol is environmental friendly option compared to diesel powered ship, and that regarding the greenhouse gas emissions, biomethanol represents even more friendlier option than fossil methanol. But regarding the NOx and SOx emissions, the comparison shows some types of biomethanols have higher emissions than fossil methanol. Due to that, the further analysis is performed where the well-to-pump phases of each type of methanol, including fossil methanol and biomethanols, are compared, and this analysis indicated that biomethanol produced from forest residue represent the most ecological option among analyzed. Its use as a ship fuel resulted in lower SOx emission, NOx, and CO2 equivalent emissions. Regarding the CO2 equivalent emissions, fossil methanol has the greatest contribution to the global warming among considered types of methanol, which is obvious. When observing the NOx emissions, the highest has the biomethanol produced from poplar, while it's evident that the production of biomethanol from switchgrass has the highest SOx emissions. In conclusion, methanol is investigated as a marine fuel used in a dual fuel engine on board short sea, on board the Croatian ro-ro passenger ships. Along with fossil methanol, 6 different types of biomethanols are investigated. Their environmental impact are investigated and compared with the existing power system on board a ship. The life cycle assessment comparison showed that even fossil methanol is the environmental friendly option compared to the existing diesel powered ship, while among different types of methanol, biomethanol produced from forest residue showed the lowest emissions. And methanol and either fossil or biomethanol offers lower emissions during the ship operation, and it will be reduced to environmental footprint of the Croatian ro-ro passenger ship. However, further development of bunkering facilities and distribution chains of methanol are required in the future. And thank you for your attention.
Okay, thank you for the nice presentation. It was our last paper in this session. Do we have any questions for Maya? No, we don't have. Do we have any questions from Claire, DeMarco? I think no. So it's the end of session. I'm going to close the session. So thanks again to everybody for your nice presentations. We will have a break right now, and after that a special session will be started. And after that, for the papers presentation, it's gonna be start at 7:15 according to Turkey time, and 4:15 for Central European time. You can join that sessions. The session subject is materials, so you can follow that session at 7:15 according to Turkey time. So thanks again, everybody, for joining our Congress. So see you in next sessions.